All right, let's jump right in. We're going to tackle a huge question today. How do you build software that can actually handle the real world, without just falling apart? We're going to go on a journey from a simple idea all the way to a production-grade system that just works.
I mean, really, think about it for a second. Those massive apps you use every single day, the websites you rely on for work, they're handling millions of users, constant updates, crazy spikes in traffic, and they just stay online. How is that even possible? Is it just luck? Some kind of dark magic?
Well, of course not. It's not magic. It's actually a super disciplined, repeatable process. And the best way to think about it? It's like building a skyscraper, right? You don't just show up and start stacking bricks, hoping for the best. No way. You start with a detailed, really well thought out blueprint. And that's exactly where we're going to start. So, this brings us to our first and, honestly, most critical stage, the blueprint. Get this, before you write even one single line of code, the success or failure of your entire system is pretty much decided right here, in the planning phase. If you get this part right, everything that comes after gets so much easier. And this quote, man, it just nails it. The simple act of writing things down, just putting your plan into a document, we usually call it a technical design document or TDD, it forces you to think through every single detail. It's amazing how it exposes flaws in your logic. And the best part, your whole team can look at it and give feedback before you sink weeks or even months into building the completely wrong thing. Okay, now this is where it gets really interesting. This shows the incredible power of asking the right questions up front. These aren't just tiny details. These are the fundamental choices that will literally shape your entire system. For example, you ask about scale, boom. The answer tells you if you need something like Cassandra or if a simple PostgreSQL will do. You ask about availability, say 99.9% uptime versus 99.99%. That little 9 is the difference between having maybe 9 hours of downtime a year and just 52 minutes. And that one decision determines if you need a super complex, multi-region architecture. See? Every single one of these questions forces a massive decision before you've even started coding. All right, so our blueprint is solid. We know what we're building. Now it's time to pour the foundation. And in the modern world, we don't do this by hand anymore, clicking around in some web console. We build our infrastructure, all of it, the servers, the networks, the databases, we build it with code. Think about the old way of doing things. Setting everything up by hand was, so slow and just begging for human error. It created these inconsistent environments that led to that classic, super frustrating problem. But it works on my machine, right? Well, infrastructure as code, or IAC, is a total game changer. It's predictable, it's repeatable, it's fast. And best of all, it's versioned and reviewable just like the rest of your code. It takes this risky manual art and turns it into a safe, reliable engineering discipline. So how does this actually work in practice? Well, it follows this beautifully safe workflow we call GitOps. It's simple. Step 1, you code the change you want to make in a file. Then, an automated system generates a plan that shows you exactly what is going to change. No guesswork. Step 3, your team reviews that plan in a pull request. This is key, no surprises. And only after it's approved does the pipeline go ahead and apply those exact changes. It's just a safe, totally transparent, and auditable way to get things into production. Okay, so we've got our blueprint. We've got our automated foundation. Now our skyscraper needs its engine, right? We need a standardized way to package and run our application code on top of everything we just built. And for that, we use containers. Just think of a container image as this perfect little self-contained box. It has your app and literally everything it needs to run inside. It's the atomic unit of modern software. But there's a catch, and it's one that almost everyone gets wrong when they're starting out. The size of that little box, it matters a lot. It impacts your speed, your costs, and maybe most importantly, your security. So if you just build a container image the most obvious way, you can easily end up with something huge, like 800 megabytes. It's totally bloated. It's got a whole operating system in there, all the tools you use to build the app, none of which you actually need to run the thing in production. It's just dead weight. But what if I told you we could take that exact same application and get it down to this, under 50 megabytes? That's more than a 90% reduction in size. It's a massive difference. So the big question is, how on earth do we pull that off? The answer is this brilliant technique called a multi-stage build. And it's so simple, it's almost genius. Here's how it works. You use a big temporary workshop container to build and compile your code. Then, when it's done, you take only the finished product, just the app itself, and you copy it into a second, super clean, minimal container that you'll use for production. All that junk from the workshop, it just gets thrown away. The result is a much smaller, way faster, and dramatically more secure application.
Okay, this is a concept that trips up a ton of people, so let's break it down. When you're running containers, an orchestrator like Kubernetes is constantly checking on them with two different probes. The Liveness probe is basically asking your app, hey, are you alive? Are you completely frozen? If the app doesn't answer, Kubernetes just restarts it. Simple. But the Readiness probe asks a different question. Okay, I know you're alive, but are you ready for traffic? Can you handle users right now? If the app says, nope, still starting up, then Kubernetes will patiently wait before sending any users its way. Getting this difference right is absolutely crucial for a stable system.
All right, our skyscraper is built, the engine is running, but we're not done, not even close. Now we have to build the watchtower. We have to be able to see everything that's happening. We need to make the system observable so we know instantly when something is wrong, and even more importantly, we know why. So what should we be watching? I mean, you could drown in a sea of 1,000 useless metrics. So we don't do that. We focus on what are known as the 4 golden signals. These are the 4 things that actually matter to your users. First, latency. How fast is it? Second, traffic. How much demand are we seeing? Third, errors. What's our failure rate? And finally, saturation. How full is the system? How close are we to tipping over? If you just watch these 4 things, you will catch pretty much any problem that comes up.
Now, imagine one of those alerts fires at 3 in the morning. The absolute last thing you want is a sleepy, panicked engineer just guessing what to do, and that's where a runbook comes in. It's a structured, step-by-step guide that's linked directly from the alert. It tells the person on call exactly what to check, what commands to run, and what to do. It literally transforms that moment of chaos and panic into a calm, clear procedure.
So here's a super simple example. An alert goes off, a server's disk is almost full. The runbook tells the engineer, Step 1, run this exact command to verify the problem. Step 2, check for big log files with this command. Step 3, try to fix it by truncating the log file like this. And finally, Step 4, if this doesn't work in 15 minutes, page the storage team. See? It's clear, it's actionable, and it's incredibly effective. And there you have it. We've gone the whole way. From the blueprint in a design doc, to the foundation built with code, to the engine running inside optimized containers. All of it being watched over by our observability watchtower. We haven't just built a piece of software. We've built a living, breathing, resilient system. Look, this lifecycle, it's not some kind of secret. It's a map. It's a clear, well-defined path that leads to building better, more reliable software. This is the map to operational excellence. So the only real question left is, are you ready to build?